Indian agriculture presents a glaring paradox. Farmers are pouring record amounts of chemical fertilizers into the earth, yet their overall crop yields are completely flatlining. This chart tracks a vital metric: how much food grain is produced for every single kilogram of fertilizer applied. In the 1970s, 1 kilogram of fertilizer yielded 13 kilograms of grain. Today, that number has plummeted to just 4 kilograms. The root of this decline is buried underground. Decades of prioritizing immediate, maximum yield have stripped the earth of its organic matter, leaving behind a chemical composition that no longer supports natural growth cycles. India is trapped in a soil degradation crisis. The earth is so exhausted that adding more synthetic chemicals no longer produces more food. It simply creates an expensive, unsustainable loop. This map from the Center for Science and Environment reveals the severity of the damage. The widespread red areas highlight where soil is severely lacking in nitrogen, a deficiency now affecting 64% of all tested samples across the country. Healthy soil requires an ideal NPK ratio: 4 parts nitrogen, 2 parts phosphorus, and 1 part potassium. But heavy subsidies incentivized farmers to dump cheap urea, warping the national average into a toxic ratio of 6.7 to 2.4 to 1. Looking at this graph of state-by-state fertilizer use, the regional disparity becomes obvious. Southern and eastern states hover closer to the ideal baseline, while the extreme spikes on the right side show massive imbalances in northern states like Rajasthan. To stop this chemical damage, the Indian government launched a massive intervention, the Soil Health Card Scheme, reaching 140 million farmers across the country. The card works like a personalized medical prescription for a plot of land. It tells the farmer exactly which micro and macronutrients their specific soil is missing, and provides exact dosages to correct the imbalance. By mapping the chemistry of millions of farms, the government intended the Soil Health Card to replace blind fertilizer dumping with a precise, laboratory-guided approach to restoring ecological balance. The logistical pipeline to generate these cards begins on the ground. A local village worker, known as a Gram Sevak, visits the farm to physically extract a sample of the soil. They collect 1 sample for every 2.5 hectares of irrigated land, and 1 for every 10 hectares of rain-fed land, creating a massive, standardized grid across rural India. That sample travels to one of 1,454 national testing labs. There, it undergoes chemical analysis to measure its nutrient profile before the results are finalized into a printed card and delivered back to the farmer. But generating millions of data points means nothing if the data goes unused. To see if this expensive pipeline actually works, we can look at an impact study conducted right here in the Sri Ganganagar district of Rajasthan. The government built a massive bureaucracy to deliver precision science directly to the field, but that information completely failed to change how farmers manage their land. Digging into the crop-specific data from the Sri Ganganagar study reveals exactly why the system broke down. In the cotton fields, data actually showed a slight decrease in urea usage, but farmers weren't following the soil health card. They were reacting to a devastating whitefly infestation. Because whiteflies are attracted to the lush growth caused by over-fertilization, farmers aggressively cut back on urea to save their crops. We see the true baseline in the wheat crops. Here, fertilizer usage remains stubbornly stagnant. Farmers ignored the government recommendations entirely, applying the exact same chemical load whether they held a soil card or not. This disconnect is driven by human friction. Many farmers deeply distrust the system because the local workers pulled soil samples from their land without ever consulting them or explaining the process. The practical hurdles pile up quickly. The printed cards use technical jargon that is difficult to read. The lab results frequently arrive months after the planting season has started, and the standardized sampling grids are so large that they completely ignore the varying soil conditions across a single farmer's fragmented plots. Even a high-precision laboratory report loses its value when it arrives via a delayed bureaucracy and fails to account for the actual soil variations across a farmer's fragmented fields. When you look at the demographics of the few farmers who do successfully adopt the soil card recommendations, a clear pattern emerges. Adoption correlates heavily with those who have higher levels of education and larger landholdings. This is a classic problem of information economics. Scientific data is only actionable if the recipient has the socioeconomic resources to decode it, the financial liquidity to buy different supplies, and a reason to trust the source. The top-down mandate of the soil card directly clashes with the Indian knowledge system, a tradition of localized farming wisdom built on centuries of direct physical observation of the land. Traditional Indian agriculture relies heavily on participatory, farmer-to-farmer knowledge transfer. It requires dialogue and shared experience, which is the exact opposite of an opaque government worker silently taking a dirt sample and mailing back a spreadsheet. Because of this systemic disconnect, farmers in Sri Ganganagar consistently reported that they prefer to trust the familiar, face-to-face advice of their local private seed shop owners over the distant authority of a government laboratory. Fixing this last-mile problem requires scaling down the sampling grids to reflect the reality of highly fragmented, varied plots. It requires carefully blending modern laboratory analysis with the localized traditional wisdom that these farmers already understand. India cannot save its dying soil through chemical diagnostics alone. Healing the earth requires rebuilding trust on the ground and integrating farmers as functional partners in the scientific process.